This is Benes Selvanesan, Assistant Professor, Department of Electronics and Communication Engineering from Rogini College of Engineering and Technology. In this video, we are going to see about the introduction and programming of an Arduino. What is an Arduino? Arduino is an open source electronic prototyping platform based on flexible, easy to use hardware and software, which can be programmed, and a ready-made software called Arduino IDE, Integrated Development Environment, which is used to write and upload the computer code to the physical board. The key features are Arduino board are able to read analog or digital input signals from different sensors and turn it into an output, such as activating a motor, turning LED on or off, connect to the cloud, and many other actions. You can control your board functions by sending a set of instructions to the microcontroller on the board via Arduino IDE. Unlike most previous programmable circuit boards, Arduino does not need an extra piece of hardware in order to load a new code onto the board. You can simply use a USB cable. Additionally, the Arduino IDE uses a simplified version of C++, making it easier to learn the program. Finally, Arduino provides a standard form factor that breaks the function of the microcontroller into more accessible packages. The main advantages of using the Arduino is not much knowledge required to get started. Fairly low cost depending on shields you need. Lots of sketches and shields available. No external programmer or power supply needed. Get started with programming. Bare minimum code. Void setup of. It puts your setup code here to run once. Void loop off. Put your main code here to run repeatedly. Setup. It is called only when the Arduino is powered on or reset. It is used to initialize variables and pin modes. Loop. The loop functions runs continuously till the device is powered off. The main logic of the code goes here, similar to while for microcontroller programming. Pin mode. A pin on Arduino can be set as input or output by using pin mode function. Pin mode 13, output sets pin 13 as output pin. Pin mode 13, input set pin 13 as input pin. Reading or writing digital values. Digital write 13, low makes the output voltage on the pin 13, 0 volt. Digital write 13, high makes the output voltage on the pin 13 as 5 volt. Int button state is equal to digital read of 2 reads the value of pin 2 in the button state. Analog to digital conversion. What is analog? It is continuous range of voltage values, not just 0 or 5 volt. Why convert to digital? Because our microcontroller only understands digital. ADC in Arduino UNO. This is the figure of the Arduino UNO, and in the bottom we can see the ADC. Converting analog to digital. This is the representation of the conversion of analog value to digital value. Quantization of the signal. The graphical representation is the quantization of the signal. The quantized signal is represented in the blue color line, and the analog signal is represented in the black color line. The sample points are represented as a dot in red color. ADC in Arduino. The Arduino Uno board contains 6 pins for ADC, 10-bit analog to digital converter. This means that it will map the volt into integer values between 0 and 1023. Reading or writing analog values. Analog read A0 used to read the analog value from the pin A0. Analog write 2, 128. This is an example of the ADC. Const int analog in pin is equal to A0. Analog input pin that the potentiometer is attached to. Const int analog out pin is equal to 9. Analog output pin that the LED is attached to. Int sensor value is equal to 0. Value read from the port. Int output value is equal to 0. Value output to the PWM. Void setup off. It initializes the serial communications at 9600 bps. Serial.begin 9600. Void loop off. Read the analog in value. Sensor value equal to analog read analog in pin. Map it to the range of the analog out. Output value is equal to map sensor value 0, 1023, 0, 255. Change the analog out value. Analog write off. Analog out pin, output voltage. It prints the results to the serial monitor. Serial.print sensor is equal to serial.print sensor value and the output value. Wait 2 milliseconds before the next loop for the analog to digital converter to settle after the last reading. Delay to this is the end of the program. So thank you.